Hello, everyone. This is Susanna Brady. I am Vice President of Americas Sales for Cobalt Digital, and I also have the role of Chairman for the Risk Forum, the marketing part of the Risk Group. So I welcome everyone to the session. Thank you so much for taking time to be here with us today. I will be starting with a quick introduction on our speaker today. Our speaker is Sergio Ammirata. Sergio, we can say his name many ways, because Sergio was born in Italy and he grew up in Venezuela and also in California. So we can say in Italian, Spanish, and in English, whichever way you want to say it. So Sergio received his PhD in physics from the Ohio State University. He's the founder and chief scientist of the software company called Sipradius. In 2016, Sergio was honored as one of the Studio Daily Top 50 creatives and innovators across the media industry. He developed and patented an error correcting protocol known as Dozer, and he received the 2018 Emmy Award for Technology and Engineering for Dozer, and also received the Society of Broadcast Engineers Technology Award in 2014 for Dozer. Sergio is also the lead developer for libRIST, our open source library for Rist, for the Reliable Internet Stream Transport Protocol. And he contributes to the VLC project. He's a member of the Video Services Forum and a very active and valuable contributor to the Rist activity group, the engineering, the technical part of the Rist group. He is not busy at all these days, so we thank you very much for taking the time to share information about libRIST with us today, Sergio. And with that, I will leave you with our audience. I just want to remind everyone there's the Q&A session box there. So if you have any questions throughout, just type it in. I will be monitoring the Q&A box, and I'll make sure I'll bring that to Sergio's attentions. And also, the presentation should last about 30 minutes. So if you don't get your question answered throughout the presentation, be sure that at the end of the 30 minutes, we will be doing the Q&A and we'll be addressing your questions. So I will leave it with Sergio, and hopefully most attendees join us by now. Thank you so much again.
Thank you, Susanna. All right, let's get started. The presentation today is going to be more a tutorial, a hands-on tutorial on how to use libRIST from beginning to end, how to install it, compile it, run it, and we'll be running two individual tests. One of them is going to be a side-by-side test where we're going to send two streams, one without protection and a second one inside a Rist tunnel, and we'll compare them side by side. And the second test is going to be multipath test. It's going to be one stream across two paths, and we'll prove the redundancy model and the redundancy split functionality of the libRIST library. So we're going to start on the first one. Let me show you a diagram before we go anywhere of what we have here. We have the presentation machine, which I'm on. That's one of the machines involved in the demo. The other one is going to be a virtual machine installed VMware, and it's going to be a pretty vanilla install of Ubuntu. It's a fresh install. So we're going to be, both machines have two network interfaces connected, and one is connected directly to a switch. The second one is connected to a network emulation device that will let us fine-tune delay, corruption, packet loss, etc. And on the first demo, we're going to be using FFmpeg on the virtual machine to create two streams. One of them here on red is going to be sent directly to my console. And on my console, we're just going to go ahead and play it with VLC across the network emulation device. The second stream, second instance of FFmpeg, is going to create a second stream, which will go to the local adapter of the virtual machine. There, the libRIST tools will pick it up, encapsulate it in a tunnel, and send it to my console, the presentation machine, where it's going to be de-encapsulated and then played also in a second VLC instance. And that's the green path here. So the very first test is we need to go and set up the VM, freshly installed VM, with the tools that we need to run the demo. So it's going to be an Ubuntu 20.04, and we're going to have only the build tools installed, and that's going to be a starting point. So let's go ahead and log into that machine. I have a console here. It's 4 identical consoles from this machine. This machine, you'll see that it says 11834. I'm going to go ahead and log in to the remote Ubuntu machine now with SSH. And you can see that it has Ubuntu installed. Let me go ahead and not get ahead of myself and do the first step. Perfect. So confirming the installation, Ubuntu 20.04. Next step is the installation of the basic packages that are needed, the dependency packages. Those are all documented in the GitHub of the library. It's pretty straightforward. There's just a small number of packages that we need to install. We go ahead and install them. It only takes 15 seconds. It's quite very lightweight. It's done. So we go to the next step. And we're going to clone the library directly from the public Git repo. And again, when doing this in the VM, I SSH into it. So there it is. Library is cloned. Next step, we're going to go ahead and compile the library. We're going to follow these instructions. And copy and paste. All right. So the library is here. I'm going to create a build folder. Enter the build folder. Run the meson command. Point it to the libRIST folder. And it creates what I need. And then I run Ninja to compile. No errors. And I'm going to do sudo ninja install to install in that operating system. So that's complete. Library is cloned, compiled, and installed in the OS. All right. Next step is we're going to register the libraries. In case of Ubuntu, not all the distros are this way. We need to do an LD config after we compile and install, and then we can test the tools themselves. So let's do this step. So we're going to do sudo LD config. And now I should be able to run Rist sender. There it is. It shows the help file. And I can also bring up the more complex URL help. So we're all set. An additional step in this machine is the installation of FFmpeg. We already did that ahead of time. It was a valuable 40 seconds that we saved. I'm going to do it here just. Run the command, and it's going to tell us that it's already installed. In your case, you're probably going to have to wait a minute until the FFmpeg installation complete. Good. So we have everything we need on the VM. All right. So now I'm going to go ahead and use the multiple consoles that I have to run the different commands that are needed. One command is going to be FFmpeg, sending the stream straight to my machine here. Another terminal window is going to be to send another copy of the stream to the local adapter on the VM. And a third one is going to be the resender tool that picks up that stream on the local adapter, encapsulates it in Rist, and pushes it all the way to my local machine. So let's start out by setting that up. These are the commands, the two FFmpeg commands that are, we're going to create a test pattern that's built into FFmpeg. That's going to be our source. And you see the two commands here. Let's go ahead and set them up. Here's the first one. Excellent. So I just started the first command that's going to stream directly to my machine. What I'm going to do to verify, I have a VLC here. It's already pre-configured to receive that data. So there it is. This is my IP, the IP of the data coming in. So we can see the straight path, straight stream, no protection, just a standard UDP stream coming from DVM here, being played by VLC. All right. Next, I'm going to go to another console. I'm going to log into the virtual. Perfect. And I'm going to run another FFmpeg to the local adapter. There's the command. So a copy of the same stream is now being sent to the local adapter on the remote virtual. The next step now, I'm going to start a resender command that picks up that stream and pushes it inside a Rist tunnel. All right, switch terminals again, log into the remote machine. Now that's my third terminal. And make sure that I'm not ahead of the presentation. These are the two FFmpeg. Let's bring the next step. I'm going to also showcase the use of our authentication, EAP authentication on the library, on the tools. For that, I need to create a password file, very much like the password file that is used on HD password, for example. And I'm going to run these commands to create the password file, and then I'm going to run the resender after that. Go ahead and copy and paste the commands needed for the password. So one of the tools is called Rist SRP password, and that's the one I'm going to run. There it is. I run the 3 lines. I run it 3 times, and you can see now what the file looks like is just a base 64 encoded string of the appropriate data. All right, now that I have this, the next step is to run the resender on the VM, and then another one, the Rist receiver on my local terminal. Let's go ahead and take care of that. Resender. Okay, resender is running now. Okay. And let's run this receiver. In this last terminal, I haven't logged in, so it's going to be running the Rist receiver. Perfect. So now you see we have the logs going on here. The screen on the lower left is the resender with the stats, appropriate stat. On the right hand side, the Rist receiver. And now the Rist receiver is going to de-encapsulate the MPEG transport stream that we push through it, and I should be able to play it on the local adapter right here. And there it is. So now I'm playing another copy of the same stream on this local adapter. Let me set that up smaller so we can see them both side by side right here. All right. There it is. So I have the one on top goes through straight, and the one on the bottom goes through a Rist tunnel. Notice that because I'm using color bars, packet loss and packet corruption, etc., is not very noticeable, at least not in the areas where the color bars are static. So for this test, you have to pay attention to this moving color bar area, the stripe, and the numbers themselves. Those are the ones that will be affected on the top, direct video, and on the bottom, you'll see that it retains perfect quality throughout. Now, in order for us to now simulate the packet loss, I'm going to use our network emulator, which is right here. This is a tool that controls it. And you can see right now, when I turned on one stream, this is the bit rate, and then the other one bitrate doubled. Now I'm going to go ahead and show you the controls for this. We have a 17.5 milliseconds delay programmed in on each direction for a total of 35 milliseconds round trip. And right now we have 0% packet loss. So I'm going to start increasing this and show you what happens. Let's start with a small amount, 1% packet loss. In the case of this color bar, it's not very noticeable immediately because it's mostly static data, but you can see here some macro blocking and some issues, and also the frames sometimes are not there. So in the interest of time, I'm going to go directly to a much higher value to demonstrate this. Let's go to 10%. There you go. All right, now it's very significant. You can see with 10% packet loss, the pattern is completely destroyed. The frames and the seconds coming in, they just freeze or display, nonsense. If this was a full-blown video, it would be totally unwatchable with a direct link. But you can see down here that the Rist protected stream, it's perfect. There's no packet loss, no macro blocking, no issues of any kind. And we can confirm that by looking at the logs of both the sender and the receiver here on the lower right. In the receiver, there's some important information. It measures the quality of the link and it reports it. It should tell us here that the quality is about 80%, and it tells you the number of, 90%, 85 to 90% because of the number of lost packets. It tells you the number of received, the number of recovered, how many are missing still, etc. So it gives you pretty detailed statistics. It measures on real time the RTT between the 2 points. Here we can see average RTT is 37, 38 milliseconds, very consistent with what we put in, and it tells you the bit rate and everything else. So let's go even a bit higher. Right now we're at 10. Let's go to 20% packet loss, which is continuous packet loss in this case. I mean, this is a pretty severe malfunction. We can see the bit rate having its fluctuations when I make the changes, but overall, you don't see an increase in the bit rates because the gaps in data are filled in very efficiently by the protocol. So you don't get a large overhead, not even when you have to recuperate missing data. Again, with 20% packet loss, you can see our stream is still perfect here on the bottom, and the top one has major issues. It would be unwatchable at this point. Like you see the numbers and the color bars. There's nothing. All right, let's go one step further, and this will be the end of this part of the demo. 30% packet loss. Anyway, you get the point. The library is designed and tested typically up to 50% packet loss on a single stream, continuous packet loss. So obviously, if you have bursts of packet loss higher than 50, it can recover as well. And we'll demonstrate that in the next test when we do our multi-path demo. So let's go ahead and put the packet loss back at 0 so that we can prepare the link for the next part of the presentation, the next demo area. You can see the direct video recover and ours still going strong as if nothing had happened. All right, so let's go back to the presentation. We did the A/B testing demo. We opened the two VLCs. We did the full demonstration. And we saw the Rist versus non-Rist effects on packet loss. These are the command lines used. It's very well documented. There's a wiki that explains every parameter. So what else can the library do? We're going to demonstrate we can multiplex multiple streams coming into a single tunnel. We can do split or redundant path. We have advanced options for compression. We have another application called Rist to Rist, where you can create a repeater, Rist, for example, Rist simple profile to main profile repeater. And we have an option for synchronized streaming as well on a time mode parameter. Here we're going to demonstrate the split mode and redundancy, basically. It's going to be the next demonstration. All right, so in this demo, what we're going to do is, let me show you the diagram so that we're on the same page here. All right. So in this demo, we have one instance of FFmpeg on the virtual machine going to the local adapter. From there, we're going to pick it up with the Rist sender, and we're going to send it in two paths, one through the network emulator and a second one through a straight switch through two separate and independent networks. Then we're going to have a Rist receiver combine the two streams, and we're going to play back the result. After we have all of this up and running, we're going to grab the network emulator and we're going to tell it to give us 100% packet loss, which is basically just pulling the plug, and we'll see how our output doesn't see any glitches whatsoever. All right. It's useful in the case of two ISPs when you want to send a stream from point A to point B that needs to be perfect regardless if one of the ISPs goes down. All right, so let's go ahead and start our demo. We need to leave only the FFmpeg that's going to the local adapter. The other one we don't need. So let's go ahead and set that up. I'm going to kill this receiver. This is the FFmpeg that was going to the directly. I'm going to stop that one. This one is the FFmpeg that we have to the local adapter. So I'm going to leave that one running. Okay, and this one on this corner, which is the old sender. Now I'm going to use a new sender that has the split path. All right, so let's go ahead and do that. All right, my Rist sender now has a split path configuration, and now I'm going to start a Rist receiver that will combine those together on my local console. Okay. Wrong one. This one. There. All right. So now again, I have a Rist sender, a Rist receiver configured differently for a dual path. On the upper right-hand side is my source going to the local adapter, and the upper left-hand side right now is empty. I'm going to exit that virtual. I'm going to use that one to show just a bandwidth manager on my local adapter to show you that I have basically two interfaces, each of them with the same amount of data coming in. And then we'll see how one of those goes down. Now for my playback device, we have this one up here. It's useless because now there's no stream. And the one that we're interested is this one, the one that's coming through the Rist tunnel. It's the same playback device. So we're pretty much ready. It's all set up. We have a stream, we have dual path, and we have a player on my local console. So the next step, okay, go ahead and do transparencies. We got the sender. We got the receiver. We did the full redundancy. You can also do load balancing with different weights. In our case, we didn't. Okay, resender command line. Okay, and we opened the VLC, as we can see there. All right, so now put them all in context again and do the final important demo, which is, here it is. Okay, so we have the bandwidth is half because we have only stream, not two going through the network emulator. And we're going to go ahead and put absolutely total packet loss, 100%. The link is down. Boom. Now you can see the bandwidth immediately went to zero going through the network emulator, and you see some hiccups here in the log, that notice that, but it was a seamless transition, seamless recovery. You can see the playback didn't take a hit, and the statistics show that there is no packet loss. Everything is 100% recovered, regardless of the fact that we lost one of the two links. So that's pretty much the conclusion of the second part of the demo. Is a split path with redundancy, and we completely turned off one of the two paths, and so that there was no effect on the video. All right, so summary, you see how easy it is to compile the library in a fresh machine, fresh installed on a VM, on a VMware, or perhaps a cloud. You see how easy it is to use the built-in tools as production tools to establish links with the advanced feature. And you can take advantage of any of the advanced feature, whether it's authentication, encryption, split path, or load balance among multiple links, etc. So thank you very much. The next thing we're going to do is we're going to start the Q&A section. Thank you.
Yes, so we have a few questions already. So let me ask the first question. Can the library be used for commercial purposes? And are there any legal restrictions or requirements when it's used?
Yes, the library can be used for any purpose. It's open source, but it has a BSD type 2 license. It's a very liberal license, even within the open source, that lets you use everything for commercial purposes. You can include the library in your projects, you can modify it, and you're not obligated to contribute the changes back. They can be just private to your own source code base. So yes, it's very, very, very flexible in that regard. And there are no fees, there are no patent, no patents payments of any kind either. It's just the standard protocol.
Okay, so no legal restrictions at all.
No legal restrictions whatsoever.
Okay, we got a quick question regarding if this webinar video is going to be available later, and if yes, could you inform where? So yes, we're gonna have this webinar session available on the Rist forum YouTube channel, and all the registrants of this webinar are going to receive a thank you note with the link to the YouTube channel, to the YouTube presentation. So yes, this will be available to you in the next couple of days. I should say by Monday, it should be out. Another question is, anybody offering commercial support for this library?
Correct. There is always open source, support on the GitLab website. But if a company requires or wants to engage in commercial support, Sipradius will offer commercial support for the library and private implementations as well.
Okay, thank you. Another question is, are the tools just demo applications, or are they production quality tools? And can I use them instead of writing my own application?
The answer is yes to both. The tools themselves were written as a way to demonstrate all the features of the library itself, but at the same time, we wrote them in such a way that they can and are actually used by our own products for production deployments. A lot of the time, we recommend that you use the tools as the starting point. You run them side by side with your products, and then eventually, if necessary, you can integrate the library directly into your applications. It could be also a transition. While you get the library integrated into your product, use the external tools to use the same thing.
Okay. Does VLC 4.x can play directly the Rist stream and recover lost packets?
Yes, VLC 4.x will have Rist built in as one of the protocols. You can actually receive a Rist stream or send a Rist stream. Absolutely.
Okay. And is the library integrated in any other open source projects?
The library itself will be integrating to FFmpeg as well. We're in the process of finalizing that integration.
Okay. These are some great questions. Thank you. There's more questions here. So what happens if we get stuck during our proprietary implementation or the integration of the library? And again, it's the same question as before. Is there paid support available, or is it open source community?
Correct. I mean, we have a Telegram group as far as open source. We have, it's not a Slack, it's the other tool. We have several places where you can ask for public support for open source support, voluntary basis. But if you get stuck, the Sipradius will offer paid support for anybody.
Okay, Sipradius. Okay.
Correct.
And what about logs? Are they time-stamped? What are the important data to monitor?
The logs for sender and receivers, they all include timestamps that you can see here. The beginning of every log has a timestamp. And we pretty much have, on the library itself, there's a few parameters that are given to you on the callbacks. And then we have an expanded set of logs that come every second. The logs can be read directly by the application. And there's also an option in the library and in tools to send the log to a remote location using the UDP protocol. So you can have a central place collecting the data and graphing it or monitoring the links themselves. Pretty much everything that is relevant and important is already being printed out here on each side.
Okay, great. I'm checking here. Are there any other questions? Does anyone have any other questions at this time? These are some really good questions. Thank you. And again, this presentation will be made available in the next couple of days. You should receive an email from myself. I'm going to try to send the email just in case. If we send it from our database, it might get stuck in your junk mail or something, or as a spam. So I'll make sure I send it directly from my email address to make sure everyone receives it. There's one more question here. Is the library CPU intensive?
Not at all. Not at all. Actually, we can see here the usage, and it's quite light. Even if you do encryption, it's quite lightweight. We have done some tests, and even on our Raspberry Pi, you can do 50 megabits per second of encrypted data going through.
Okay, that sounds great. Yeah.
Here on when I sort by CPU, I cannot even see here. The Rist sender is 1.7 CPU, or the Rist, the Rist receiver in this case, under 2% of the CPU in this machine to receive that data.
So basically negligible,
yeah.
Really. A question that we get all the time. We love this question. What makes Rist better than SRT?
Well, the SRT protocol was built for file transfers, and then they modified to try to make it work with real-time transmissions. The Rist protocol was built and designed by basically the industry experts. There's several companies that had patents in the industry that have been running their own proprietary protocols for many years. They got together and we put the best of all of our protocols into what's now the Rist standard. So it was built precisely for this purpose: interoperability, recovery from packet loss, multipath. These are all elements that were part of the original design, which were not present on the SRT. The SRT filled in the gap when that was needed, but now that we have this library, it was built with all of this in mind. And of course, interoperability. There's already several vendors that have implemented the spec. There's no, in the case of SRT, there's only one source code that everybody uses. In this case, every vendor can implement their own, and they all talk to each other.
Mm-hmm. One question here is regarding the Rist profile. Are you using Rist profile 1 or 2 in this demo? Maybe he meant simple profile or main profile, right. The first profile.
Correct. Yeah, in this demo, we run the main profile with encryption. The library supports also simple profile. It's one of the parameters you pass, and then you can either send or receive a simple profile, and you can send or receive main profile as well.
Mm-hmm. Okay, there's a question that came here to all panelists. Which Raspberry Pi did you implement on this?
We tested on Raspberry Pi 4, the latest one.
The latest. Okay, great. And there's this question about commercial support for the library, which was already answered. So let's see here. Wow, this is fantastic questions. Would anyone else have a question? Of course, when I send you a thank you email with the link to the session, we're going to include Sergio's email address, so you can feel free to contact Sergio directly and ask any other questions that come up later. And again, thank you very much for taking the time to be on this session. Thank you, Kira McCarty from Zixi, for organizing this session. Thanks so much, Sergio. And checking here one more time if there are any other questions. I guess not. That's it. So
Thank you.
thank you very much, everyone, for today's session. And we are going to be offering a session almost every month. We have 5 other topics lined up and material ready for the upcoming webinars for Rist. So lots of very interesting, unique sessions that we're planning for. Already have one planned for January and February. And so I think we're going to be posting a calendar of these upcoming sessions on our website soon, so everybody can see ahead, what we're planning to do. But there's lots of great contributors, lots of wonderful, useful ideas. So we'll be getting those out on our website very soon. And thanks for you all who asked the questions. Everyone have a wonderful day. Thank you so much.